Kafka, and second part of our presentation we'll have Ondřej, and we are from Czech Technical University in Prague, and I'm from Department of Landscape Engineering and Water Management. Close? Okay, yeah. And Ondřej is from Department of Geomatics, and we cooperate with this project which we introduce here. And my part will be more about the motivation, and Ondra after me told you how we do these things which is in our ideas. Basically, we are focused to surface and subsurface processes in the arable land, also in some technical structure. And we are focused how it's affected the surfaces, management of agriculture techniques, and so on. And we are focused directly to the field blocks with rainfall simulators, because we need more and more data for validation of our model. But from the field, we also shift to a bigger scale and to some catchment models. And in this picture, you can see that from the UAV or from aerial photography, we also see in the landscape erosion processes, real erosion processes, which is important for us because it's different than sheet flow and sheet processes in the landscape. Yeah. And the motivation is if we know how this works in the fields, in the small scale, and if we have the models, we can use this data also from whole catchment. It's our idea because, next slide please, we make some analysis that the small catchments which have area less 5 square kilometers covered approximately 80% of Czech Republic, and the whole processes which is in this small catchment is in many part or main part of the Czech Republic. And is the motivation if we know how it's water and water management work in the small catchments, we can make some erosion control measure in this scale. And yeah, next please. And last part of the motivation is the degradation of the soil is in the landscape or in the agricultural lands. But in this picture you can see this this part. Here is also some erosion rail, and this erosion flow directly to the urban areas. And the protection of the urban areas and the knowledge where is the point where the water going to the urban areas is so more important for us, because the protection of the urban areas is also very important. And on the which is left side, you also can see this urban small areas with some catchment with some risk of probability risk of the erosion. Yeah. And last things of the motivation is that we have even-based physically based erosion model, which we for the development of this model we used the data from the field blocks, rainfall simulators, and we developed last 20-30 years this model with cooperation with Ondra and Martin Landa. In last year we also provide this model as a QGIS plugin, and but the core is in grass. It's true. Yeah? I must say it because it's in grass. Yes, yes. I remember that I must say it. And this model uses spatial data, digital elevation model, land cover, and the soil properties. And if we look to the equations in the model have two surface runoff processes. One process is for sheet runoff, and second process is separate the water flow in the rills. And this is main important things is some critical level of the water, which based on velocity or shear stress of the water in the surface. And if this critical level is, if the water is higher than this critical level, rill is growing in each or in the pixel which is we solved. And this growing the rills, for this we also need some validation data, and we must know where is the rills and where is no rills in the field, because we can after this calibrate the model also for the rills. Maybe it's on next slide, please, Andrzej. For people which don't know what is the surface runoff and the rill runoff, it's here in simulator. Here blue is surface runoff, and after some rain, it's here the water going in some path here, and it's a rill. It's different type of the runoff, and also different type of the erosion, which is the main point which we would like to solve. And this same principle we used also in the catchment scale. Maybe it's not clear, see here, but here and here we manually detect if the rills there on this picture, and we calibrate the model, the critical shear stress in the model, and we test it if we can detect the rills in the model in similar, which we know from the manually making the rills. Next, please. And you can see this is the observed rills, and the next slide is how it's work if we found the best critical water level, and where is the rills. You can see here there is more pixels have rills than it's detected by eye, and the second picture is a bit better. And this is the motivation why we would like to take many pictures with the rills in whole data which we know from Czech Republic, and we would like to detect the rills in these pictures, because if we know where is the rills, we can take the rainfall data from which is provide this rills, and we can use the model for the calibration. This parameter, the critical shear stress and critical velocity, and this is the why Ondra continue in this talk, because we used rills which with your slide, please. Maybe you continue.
Yeah. So. For the detection of the rills, we have decided to use some CNNs, some convolutional neural networks, because the rill is somehow defined not only by the value in one pixel, but also by the relationship with the surrounding pixels. So this like context-based knowledge is the critical thing for the convolutional neural networks. Firstly, the data. So all the data comes from Czechia. So whatever we say, we claim this about the data from that area. It doesn't mean that like the rills in Brazil are gonna be the same and the models are gonna work. It's open aerial imagery. So finally, after years when we were paying for the data, they opened the aerial imagery for the entire country. It's multi-temporal, although you have to write the list to them and then they will provide it to you. There is no like very like And, yeah, I'm not sure how to say it without insulting somebody. And there is no good way to reach the historical data. So we worked with these data, and they are obtainable there. For the labels, we have decided we have cooperated with a company, or I'm not sure what is the status of them, called WUMOP, and they created a manually labeled data set, because for me, I don't know really a lot about Rills, so there were some experts clicking the training data. This is how the data looked like. Unfortunately, there were some issues that, for example, the labels are lines. If you work with CNNs, you know that what you need is really for semantic segmentation, pixel-wise labels. So far, we just did some buffers that were considering the average width of a Rill. But that's not ideal, so we need the clicker to click again and do it in polygons. The types of data, as Peter said, so we worked with the aerial imagery, but to see if there is some difference, we created one more, let's call it a band or a layer or whatever you are used to, for the data, and we have used this critical water height and this H grid coming from the SMODERP model, and we compared it later if using this extra input helps the training or if the aerial data is sufficient. The CNNs, to be sure that we are not using just this like one CNN that was the best one for recognizing cats and dogs, we have decided to use a few of them. So it's FCN, which is kind of a historical Brontosaurus, SegNet, UNet, which are they are the most common CNNs in the field of remote sensing, 3 versions of DeepLab. The tricks, just to be sure that we manipulate some parameters correctly, and if it helps the training, we also used some dropout and very simple data augmentation, just rotating by 90, 180, and 270 degrees. Go on. The code is open. This is FOSS4G, so naturally it's open. So all the code for the CNNs and for the data processing, data preparation, whatever, is open. It's on GitHub. It's under the MIT license, and it has a plethora of arguments which are probably not readable for anybody sitting over there. That was a purpose. Now I can lie to you and I can say all the amazing things that are actually not there. There is a lot of arguments, so the user can really tweak the network the way he likes. It's written in a very modular way, so it's very easy to add a new architecture there, because everything is like on the background there is TensorFlow, but this is even one level higher in the way that you structure your models to make it easier for the users. So there is for sure a tool for the training. That's this one, and I'm not going to go through the parameters. They are documented on GitHub. Yeah. There is a tool for detection or prediction or whatever term you like to use. So that has fewer parameters, so it's like easier to use, but yeah, that's how it is. The results, I'm not gonna bore you with all the tables. Just the main thing is probably the bold value. Its overall accuracy reached over RGB, and the best result was reached by UNet. We also compared it with random forests to have some benchmarking model. So UNet got like 7 more % over random forests. Click, please. This is the same thing, but using also H-grid as one of the bands. We can see that for random forests, it raised the accuracy by 4%, and here by 3 or 2.3 or something like this. So again, UNet is better, but the main thing was the finding that even if you have a physical model and you want to go for the whatever people call AI or machine learning, and one of these like 57 terms, it's still worth giving a shot for the physical based models. Click please. For those that don't like overall accuracy, because it's very easy to manipulate the listeners by overall accuracy, because 95% doesn't mean that it actually does anything if 95% of the percent are one class. This is the F1 score. Yeah, go on. Probably no need to have some autistic window. This is some visualization of the results. So this is the input aerial imagery, RGB. This is the label, and this is the prediction from the CNN. This is confusion metrics, and there are some numbers that you cannot see. And this is pure RGB. This is with H-grid. So we can see that the rail, that it's this thing. The issue with the label is that as it was a line, it's just buffered now, and actually we are not even sure, when we were checking the photos recently, if this part is a rail or if the rail actually starts here. So there is some issue with the manual label. So even if you give it to the experts, they give it to the students or the cheap labor, and they just click it. In any case, it's quite similar here with RGB and with H-grid, but if you go to the next slide, then this is more interesting. So with the H-grid, we were able to get rid of most. It's actually the blue visible. Yeah, okay, good. We got rid of most of the other things, because around this green part on the forest in the field, there are these like tracks from tractors or something. They look quite similar to the Rills, but they behave in a different way. So that's why using the CNNs and using this H-grid really helps to improve the results, especially in these critical or more difficult or challenging backgrounds. Yeah, let's go further. Just to conclusions. Yeah, the Rills can be detected by CNNs. The outputs from physical models could be helpful. So don't be afraid of using the physical models. Very interesting was that dropout did not improve the performance. If you want, I can talk later more on this, why it is, because it's for another talk probably. But it happened, and it's not unique to this one. Even the simple data augmentation helps the CNN. The best results were reached by UNet, which doesn't mean that UNet is going to reach the best results. It was the best from what we tried. Maybe if you try some transformers or something, maybe it will be better. I don't know. It beats random forests. That's a nice finding. And the future work is that I have this somewhere on one of my broken laptops, where this CNN lib that I've created, there is a, yeah, I know, I will commit one day. The plan is for the next GrassGIS code sprint, where everybody is invited. Yeah, it should be changed to be a set of GrassGIS modules to force one more person to use GrassGIS. Yeah, you can go further, I guess. I'm not sure if there is. Yeah, and there are links for the software. SMODERP is actually under this like strong copyleft GPL, because we are using something. I don't remember why it's under GPL, but Yeah, because of QGIS and GRASS. Yeah, so it's under GPL 3 plus. The CNN lib is under MIT. If we move it to GRASS, it's going to be also GPL. So, yeah, that's it. And thank you.